All right, YouTube. Good morning. It's your boy AlexTrainsChest, and I'd like to welcome you to part number 14 of the injury progress update, and at this point, part number 2 of the attempted pan cleaning project. So last night, I threw some of this easy off oven cleaner on my nonstick pan, which has had years of use, to see if I could try and clean it and make the nonstick surface better. And now we're going to see what the results of that were. So I put it in this trash bag, and I can kind of see like some stuff right here. Oh, and by the way, I also put on these gloves. I don't actually have long gloves, but the active ingredient in this cleaning stuff is sodium hydroxide, and that's something that you really don't want to get on your skin. So anyway, let's see. I can see that like it seems like this looks kind of brown, so it looks like some grease has come off, so that's good. Yeah, that looks really nasty. So I'm gonna go ahead and get this pan washed off. It looks like this oven cleaner might have actually done a really awesome job, so I'm happy about that. And you know what I'm going to do while I'm cleaning this? I'm going to give you guys a little chemistry lesson. We're going to talk about why sodium hydroxide is so effective at breaking down organic compounds. Why? Because science is awesome, dog.
Alright YouTube, welcome to lesson number 1 of AlexTrainsChemistry. So I'm doing this for 2 reasons. One, because I got to talk to you guys about this pan cleaning experiment. And 2, because I'm feeling lazy and I don't feel like starting meal prep right now. So I'm procrastinating. So let's talk a little bit today about bases. We're not going to talk about acids because I didn't use an acid to try and clean my pan. We're going to talk about bases. Bases are a solution where there's a ton of hydroxide ions floating around, and that's denoted by OH minus. That would be oxygen and hydrogen minus, and the reason why it's minus is because oxygen has too many electrons, and therefore it has a negative charge. Now, do you guys want to know how basic hydroxide is? Reason number 1. It gets all its information about life from Cosmopolitan magazine. Number 2, its favorite meal of the day is not lunch, it's not dinner, it's not breakfast, it's brunch. So in the solution that I sprayed on my pan, the active ingredient was sodium hydroxide, like this. Sodium being right here. And then here's the basic hydroxide just hanging on. Now, sodium right here, sodium is chill, it's aight, but what hydroxide really wants is one of these guys. Another hydrogen to just orbit around and give oxygen the attention that it wants and maybe deserves, maybe not. What happens is sodium is like, okay, I'll just go over here and, maybe chill with these other water molecules over here, whatever. Maybe there's some sodiums hanging around this. But then hydroxide is like, well, what the heck, I'm off here by myself. separated. And I really want one of these hydrogens, but this hydrogen has already found a nice oxygen. So, in order to find hydrogens, typically hydroxide is going to steal them away from carbon. So, over here, carbon is like, oh, sick, you know, maybe I'm bonded to some oxygen, which has got some hydrogen over here, and maybe I've got another hydrogen over here, another hydrogen over here. And by the way, what do we call chemical structures like this? Typically, they're called hydrocarbons, and they can also be organic compounds, just like what's in your skin, or like what's in grease on the pan. So, one of these hydrogens is chilling right here, having a good time. It's in a covalent shared relationship with electrons with the carbon. And then basic OH minus comes along and is like, what's up, dog? I'm stacking bands, I've got mad bling, fancy cars, whatever. I'm rich. And this hydrogen's like, oh, I don't want to be hanging out with carbon all day. Carbon is what's in coal. Well, it's also what's in diamonds, but in this case, carbon's just coal in this case. It's a shitty thing that you get for Christmas. So this hydrogen goes, you know what, oxygen, maybe I'll come hang out with you. Then oxygen's just like, nah, dog, you're hanging out with me right now. Boom. And it just strips this away, and then hydrogen can come hang out with oxygen here and make a nice little water molecule. So it's no longer minus. And that right there is why really basic solutions will completely wreck your skin, and also why they'll wreck other organic compounds, aka the grease that's on my pan, and get it off. Unfortunately, they also wrecked the non-stick surface on the pan. So there we have it, guys. That is lesson number 1 of AlexTrainsChemistry.
Okay, so the pan is cleaned off, and unfortunately I discovered something kind of interesting. So see this spot right here? So that's actually, let's see if we can get a close-up view of this. So that's actually a spot where the non-stick coating has actually come off a little bit. You can see the little ridge right there. And so at first I didn't think that these pans were coated with anything, but it turns out they are. So that's kind of a bummer. The other thing too is that on these rivets there's this kind of like intense stuff, like very, very hard, like almost like calcified material on here that is very difficult to get off. And I'm really worried that that's some kind of like sketchy compound that's on there that I don't really want to be eating. So I think unfortunately I just ruined this pan. So there you go. You try and experiment. Sometimes it doesn't work out. If you guys are trying to clean a pan, a non-stick pan, don't use this stuff. I did some reading online. It says that it's okay to use probably on cast iron, which makes sense because cast iron doesn't have like any non-stick coating on there. Only thing about cast iron is if you throw this on cast iron, if you season the pan, which you have to do with cast iron stuff, then you'll have to like start all over again with getting that back, getting that like nice oil coating back. So, moral of the story, this will clean your non-stick pan, but may also take off the non-stick coating, so I recommend against using this for that.
Dude, wasn't that lizard footage just like absolutely incredible and breathtaking? I mean, I think that I should submit that footage to a BBC documentary. Anyway, got down to about 16 inches from what I'm calling 28.75, and that's the same as yesterday, so meh. I did try to run this morning, and I got around the block a couple times, which is good. It was still painful, but I got further than before, so I'll take it. I kind of lift today. And now we will go into the lay down leg raise test. And here it looks like I got a little bit higher, up to 22 inches. So that's legit. Calculating that angle gives me 34 degrees. So yeah, buddy! And here now for the stability test, I'm just going to jump straight to the bad side. No reason to watch the good side because that side feels good. So again, we set the timer up for 15 seconds and made it to 15 seconds on this one, as you'll see. So anyway, with that, AlexTrainsChest, checking out.